Okay, so this is lesson 2-4, part 1. A year ago, we were in lesson 3-4, and there was a part 1 and a part 2 because I broke it into long division and then synthetic division. We're going to do the same thing. We're going to do long division, and then we're going to do synthetic division. So, with that in mind, our first example asks us to use long division to find the quotient and the remainder when this is divided. Now, we need to do a little bit of long division review. Like, how do we do basic long division? Like, how do I do 96,456 divided by 25 without the calculator aid? Let's review real quick before we actually do the problem we need to talk about here. What do you do?
25 going to 96.
Okay, 2 digits, 25, into 2 digits, 96. How many 25s in 96? 3. Where do I put that 3?
Under 6. Well, yeah.
We're dividing by 2 digits, so it goes 2 digits in, right? Then what do I do with that 3?
Multiply by 3.
Okay, so we take this number, we multiply it by what's out front. 3 times 25 is 75. Then what?
Subtract.
We subtract. This is ringing bells. Yes, this is like taking us back to 4th grade. Okay. 96 minus 75.
21.
I'm going for 21.
Sorry, I got dyslexic there.
Exactly, no problem. 21, now what?
24. Oh, bring down the 4. Bring down the 4.
Bring down the 4. Now it's 25 into 214. 8 quarters and $2, right? 8 goes above the next digit. 8 times 25? 200. Or 8 times 5 is 40. Carry the 4. 8 times 2 is 16. Plus my carried 4 is 20. Then we're going to subtract 214 minus 200. 14. And then? Okay, long division is coming back to us, right? 25 into 145.
5.
I think quarters here, right? So yeah, 5. 5 times 25. Well, yeah, 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus the carried 2 is 12. 145 minus 125. 20. And bring down the 6. 25's in 206.
8.
8. Because 8 25s we already did is 200. 206 minus 200 is 6.
Yep.
If we wanted, enough to add a decimal, add zeros, and keep going, yes.
Oh, I got it.
Long division of polynomials, we don't do that, though.
You only have to do it twice.
Okay, well, I'm not doing any. Okay, when you first learned division, you just got to say R6. Those were the days, right? I'm looking for the intermediate. My answer is 3,858 and 6
Hundreds. 25ths. 25ths.
25ths. Because it's the remainder over the divisor.
Wow. That's so long ago.
I know. My morning class didn't care for the fraction piece either. So, my algebra too, because we did the same type. Okay, I've got to get your brains back into long division. Like, I know. Been there, done that. It's been a while. So, we were asked to do this with this lovely problem here, though. So, let's set it up. Now, some things to watch out for. What's going in the box?
2x to the 4 minus x minus 2.
Except, there's a catch.
It's okay.
Don't you have to do the x squared and the x?
Yeah. You want all places represented. So if you start with x to the 4th, we have an x to the 4th. After x to the 4th, we have an x to the 3rd. After x to the third, we should have an x to the second that we don't have, so we're going to say plus 0x to the second. After x to the second, we should have x to the first, so plus 0x, and then minus 2. Divided by?
Do you have
About 2x squared plus x plus 1. Now, I went too fast there. Did I need placeholders there?
No.
That one I have x squared, x constant, so we're good. Okay, so that's one thing. Now, you remember what you're doing? Okay, we technically have 3 terms we're dividing by, so we're going into 3 terms. But what I need you to look at is just first terms here. When we were little, we would say, how many times does 2x squared go into 2x to the 4th? Or think 2x squared times what is 2x to the 4th? Two x squared times what is 2x to the 4th, and it should be x squared. If your brain's not clicking there, just divide them. What is 2x to the 4th divided by 2x squared? And that is x squared, yes? Now, where does that x squared go in my answer?
Above top is 0x squared.
Okay, up top, above the 0x squared. 2 reasons. 1, it's an x squared. It should always end up, if you have all the places set up correctly, it should always land on top of a like term. So x squared goes over 0x squared. The other thing, we're dividing by 3 terms, so you should count in 3 terms if you have all your placeholders there appropriately. And if someone ever tells you, oh, you can do that division without the placeholder zeros, you can. Things just aren't lined up and nice and neat, and it makes it a little bit harder to follow, in my opinion. I'm always going to teach placeholder zeros. If someone wants to argue you can do it without them, not going to disagree. Okay? Just not going to encourage it. What do we do with this x squared? Multiply it, yes? So it's x squared times this stuff over here. X squared times 2x squared is 2x to the 4th. X squared times your middle term, x squared times x is about x cubed, and x squared times 1 plus x squared. So I just took my x squared there and I distributed it to the 2x squared plus x plus 1. Okay, after you multiply, you're going to subtract. 2x to the 4th minus 2x to the 4th. It cancels. If it doesn't cancel, you didn't do it right. Yeah, you defeated the purpose of the problem here. So that cancels. Negative x cubed minus x cubed. Negative 2x cubed. We are subtracting, folks.
What?
We are subtracting. So negative 1 minus 1.
Okay.
Okay? Otherwise, my 2x to the 4th wouldn't have canceled out. So you're subtracting all the way along. 0x squared minus x squared.
Minus x.
Negative x squared or minus x squared. Repeat. This time, 2x squared into negative 2x cubed. Oh, whoa. What did I forget to do?
Bring it in.
You already brought it down without me, right? Bring down your next term. Now repeat. I had a moment of forgetfulness. How many times does 2x squared go into negative 2x cubed? Or 2x squared times what is negative 2x cubed? Negative x? Okay. Or again, if you don't like that, just divide them. What is negative 2x cubed divided by 2x squared? Where am I putting that negative x? Above the 0x is my next empty space. It's a corresponding place value. Multiply. Negative x times 2x squared. Negative 2x cubed. Negative x times x. Minus x squared. Negative x times 1. Minus x. Okay, now we're going to subtract. Negative 2x cubed minus negative 2x cubed. They cancel, right? Negative x squared minus negative x squared. Cancel. It wasn't part of the plan, but they canceled. 0x minus negative 1x. 1x, right?
Yeah.
0 minus negative 1. Okay. So that is a plus 1. And officially we should bring down the minus 2, yes? Now, officially we're supposed to restart the process. How many times does 2x squared go into x? We can't do that, right? And here's the deal. We can't also do this because we're dividing by 3 terms. How many terms do I have here? 2 terms. So you could think of this as a plus 0 here if you want, but we're done is what it comes down to. So a little bit of vocabulary. X minus 2 is my remainder. X squared minus x is my quotient. Answer to a division problem. Quotient. Okay. Now, more likely, you might be asked quotient and remainder, or when you express this answer, kind of think here where I did my fraction remainder, except you either have to add or subtract that fraction. So my answer is going to be x squared minus x plus my remainder of x minus 2 over the original divisor of 2x squared plus x plus 1. That is your official full answer there.
How do you know to add it?
Add it because my top term, just x minus 2, is starts with a positive there. If you had, just like a remainder of negative 2, you could say minus 2 over the 2x squared plus x plus 1. So if you just had a negative remainder, you could say minus. Does that make sense?
What if you're dividing by
Or, if you had a negative down here, it would be the same thing. If one of these terms is a negative, you could put the negative out front. Now, if it's 2 terms and just the first term is negative, not so much. But if it's just like a negative number. Does that answer your question, Autumn?
Yeah.
Maybe. She's not convinced.
No, it's just, so you only divide the first term.
Pretty
that's
much.
The only term that you're actually dividing is the very first thing that happens. And
Yes.
then when you're multiplying or whatever, then you multiply by the whole.
Right.
First. Okay.
Yeah. So everything's based on what happens when you divide the first terms.
Okay.
And then the rest of it is just it'll kind of work itself out. Okay? In other words, if it didn't go nicely, then that's the first thing the next time. Okay? So yeah, you really only look at the first thing in this case.
Okay.
Kind of like, if you think about it, I don't know, when you first were taught 25 into 96, were you taught to just think 2 into 9 to get a ballpark, maybe? I don't know. Okay. Maybe not. Maybe I'm way off base there. What can I say? I don't think I've ever taught division. Except maybe I helped Natalie learn division during COVID because she was in 4th grade during COVID. So,
Just talks for 4th grade, so
Well, Natalie had Cox for 4th grade, but it was during COVID and they were trying to learn division during COVID.
She
So.
did a lot of just hands-on work.
Yes. Well, and I felt like she taught, and I know it's what you're supposed to do these days, She taught like 20 different methods, it seemed like.
At the same time?
No, it's like they learn a method, then they teach
She
another
would do
method.
one,
And
and then she'd be like, "Well,
Yeah.
if you want to learn a different way to do it, this is how you can do it."
yeah. And my struggle as a mom was when as a mom math teacher, my child comes home and says, "Can you help me with this?"
And
Okay,
she
let me
just-
see your examples because I can teach you long division, which Natalie had at that point, but it's okay. What's this method? Like, I had to kind of learn the methods to help her along. But
600 methods to do everything.
yeah. Sorry, I am not that person. I do sometimes show 2 methods, but
Really okay.
Yeah.
I tend to just be here's a method, go with it. Now, I will sometimes say, like, do you have to put the placeholder zeros? No. And if someone wants to argue, no, you don't need those. Don't argue. It's true. You don't have to have them. But if you don't have the placeholder zeros, when I go to, like, subtract, things aren't lined up.
It just makes it easy.
Like, you're going to have this plus x squared under this minus 2, and they're not like terms, and it's just, yes. Yeah. Okay. Sorry, I only gave you 1 long division example today. I think you have like 3 or 4 in homework. Okay. Now, at most, like, I really think it's like, I want to say like 1, 2, 3, and 5 are long division, maybe. At most. So that's 4 at most. I don't remember exactly. Now, okay, we have 2 key topics. Let's enjoy the easier part of life now. The remainder theorem. Okay? The remainder theorem says if a polynomial is divided by x minus k, so just that linear piece there, then the remainder is whatever f of k is. Okay, that's all fancy speaking. You're saying you said this was going to be easy, Mrs. Sargent. Give me a chance, okay? And I promise it's easy. The idea here, so this x minus 2, that's of the form x minus k, right? Okay, because what they're asking here in example 2 is find the remainder if f of x equals 3x squared plus 7x minus 20 is divided by x minus 2. Could you do this using long division? Go for it. More power to you. You'll get the same answer that I'm going to get here in a moment. But the remainder theorem says, okay, if you're just dividing by x plus or minus the number, you take that k value and you plug it into the equation, and that will give you your remainder. Now, if I have x minus 2, what's my k value? 2. And the k value is just the 2. Now, here's my suggestion how to think about that. Think about this if it's x minus 2 equals 0, what does that end up being? That ends up being positive 2, yes? So if they give it as a factor form, you're going to do that. So my job then is to find f of 2. That's going to be the remainder of the problem. So I'm going to take 2 and I'm going to plug it in. Are you with me? 3 times 2 squared plus 7 times 2 minus 20. Do some math. Did you get what I got? I got 6 when I did my math. I got 12. 2 squared is 4, times 3 is 12, plus 7 times 2, so 12 plus 14 minus 20, I got 6. Guess what? If you were to divide those using long division, you'd get a remainder of 6. Okay, so I'm not letting you down. I told you it was easy, yes? Okay. So B, can you do B?
Yeah.
If they want to know what you get as a remainder when you divide x plus 1 into 3x squared plus 7x minus 20. What do we know here? What value am I going to use for k? -1, right? Because it would fit the form of x minus -1 would give you the x plus 1. So your k value is -1, so I'm finding f of -1. Maybe?
Too good.
can have a negative remainder. Nothing says you can't. So 3 minus 7 minus 20 is negative 24. Negative 24 is my remainder.
You have no remainder.
Let's find out.
Ooh.
Okay. If it's x plus 4, what value are you using as k? Negative 4. So plug it in. F of negative 4 is, let's see, 3 times negative 4 squared plus 7 times negative 4 minus 20. Negative 4 squared is 16. 3 times 16 is 48, I believe. 7 times negative 4 is negative 28. 48 minus 28 minus 20 is 0. So what is that? A remainder of 0. No remainder. Okay? Now, that leads us to the next piece here. A remainder of 0 says that these divide nicely, right? They divide out evenly. No remainder. No remainder means that they are factors of each other. And that takes us to the factor theorem. Okay? The factor theorem says a polynomial function f of x has a factor x minus k if and only if f of x or f of k equals 0. Well, what was f of k just finding us earlier? The remainder. So what is this saying? If the remainder is 0, then that means x minus k is a factor of the original piece. Like you could take the original piece and factor it, and that would be one of the pieces. If the remainder is 0. Now, how we're going to apply that? The question says, state whether the following are factors. So these are yes or no questions. Yes, it's a factor, or no, it's not a factor. Yeah, you just find out is the remainder. Now, are you paying attention? Did you save yourself some work, or are you redoing the same work we just did? I don't know if you caught it or not. So x equals 2, or x minus 2. What's that mean my k value is? K is 2. So that means we need to find f of 2. Well, I don't know. Did you guys notice this is the same function from up above? Did we do x minus 2 up above? So what was f of 2 from up above? 6, yes? So that means my remainder is 6. What does that tell me? Okay. 6 does not equal 0, in case you weren't aware. And so x minus 2 is not a factor. Okay. What about x plus 4? What is my k value there? Negative 4. If you plug negative 4 in, f of negative 4, didn't we already do this one? F of negative 4 is 0. So my remainder is a 0. If the remainder is 0, what's that tell me? It is a factor. I guess I said these are yes or no questions. I'm writing factor or not a factor. Same idea, right? What about C? What's my K value? Negative 3. So, what is f of negative 3? What? It is. Have we already done this one?
No,
You have to do this one, right? Okay. Had to throw 1 on there to make you think. So 3 times negative 3 squared plus 7 times negative 3 minus 20. So 27 minus 21 minus 20. 6 minus 20 is negative 14. So this is your remainder. And what do you know about negative 14? It is not equal 0, so this is not a factor. Told you, there's some easy stuff here, isn't there? Yes.
Okay, so on a test, if it's asking if it's a factor or not a factor, if we don't show our work and like all we do is put it in the calculator, will we get points off? Or like even on homework?
I would need you to show, at least tell me like what the remainder is as your proof that, okay, it's a factor or not a factor.
So like if you said, for this last one, like if I said f of -3 equals -14.
And then said not a factor,
Yeah.
I would get it.
Okay.
Because I would get that somehow you did the math to come up with that. Don't just say not a factor, like, tell me what the remainder is.
So that only works when it's like x plus something.
It only works when you have a linear factor, like x plus or minus a number. Okay? And when we talk about synthetic division, that's the only thing that'll work. Okay. Example 4, you've done this before as well, because it came up in my notes yesterday for Algebra 2. Write the function of degree 4 and leading coefficient of 2 that has these zeros. You guys remember how to write these zeros as factors? Because that's what you're doing here. I'll start backwards. 8. A 0 of 8. What is that as a factor? X minus 8. A 0 of 4. What is that as a factor? A 0 of 5. X plus 5. What about a 0 of 0? X. A leading coefficient of 2 means there's a 2 in front.
So is that just?
You would just have to multiply it out then. Okay? You would just have to multiply it out. So I would say go ahead, try the homework. You should, I mean, most of it should go pretty quickly, pretty easy. It's not a long homework. 27, 28 are probably these two. So we can talk a little bit more on Monday if we need to. Okay? I'll write this down real quick. Because I forgot to do that this morning, I guess. Page 200, 1 to 3, 5, 13 to 24, 27, whoops, 28. If you multiply this out, you would end up with that final answer.